let's look at question 6 here from the review sheet. Suppose the mean value, blah, 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 is 65, and the population standard deviation is 4. So the mean is 65, and the standard deviation is 4. Those are both in millimeters. It says that 30 adults were selected. Answer the following questions. Well, if my sample size is 30, there's a pretty good chance that this distribution is approximately normal. By this distribution, what I mean is the sampling distribution, where n equals 30, the mean is 65, and the standard deviation is 4 over the square root of 30. So we've asked about 95%. I'll recall that that's 68, 95. So 95% of the data is in here. 95% of the data is within 2 standard deviations. So 2 of these standard deviations. And I don't know this off the top of my head, so watch me pull a rabbit out of my hat. 4 divided by the square root of 30. There's 1 standard deviation. There's 2 standard deviations. So I need to go now 65 plus or minus that. So I'll stow it into x and go 65 minus that and 65 plus that. And so the answer there for these 2 blanks is those 2 numbers. So this is 63.539 and 66.461. And I should be concerned about millimeters here. That'd be a good thing. Part B says approximately 0.3% of the time. And this reminds me of the 99.7. So let's see. So now I've got 68, 95, 99.7. So 99.7 is inside those dotted bars. 99.7 is in here, which means 0.3% is outside of those bars. And so that's this blank right here is going to be 3 standard deviations, or 3 times 4 over the square root of 30, or 3 times 4 over the square root of 30, and I get 2.19. So approximately 0.3% of the time the sample mean is farther than 2.19 millimeters from the true mean.